Thank you for joining us. Dear participants, thanks for joining us for Hex-Ray IDA Teams, a new edition for a collaborating work webinar. Software Sources is hosting this event, and I happen to be its founder and CEO. We are proud to serve as Hex-Ray distributor for many years for Israel and India. So please use us as your local point of contact for any inquiries you might have. I will transfer now the stage and the mic to Arnaud and Igor from Hex-Ray R&D team, who will dive into the technical part, which is much more interesting. By the way, we will have a Q&A at the end of the session. So you can please keep your question to the end of the session, and Igor and Arnaud will answer them. So thanks a lot, and take the stage, please, Arnaud, and you can start.
All right, thank you for the introduction, Haim. Indeed, thank you very much. Thank you very much all for attending. The idea here is to present IDA Teams to IDA Pro users, especially, but not only. And to do that, we will first. I intend to first give you a very high-level introduction to what IDA Teams is and how it works, essentially. So, the idea behind IDA Teams is to bring collaboration to the reverse engineering space, because we have noticed over the years that there is a strong trend with a set of plugins popping up every now and then, whose goal is exactly that, to enable collaboration across a team of reverse engineers. Now, all of those plugins that we list a few just here, but there are many others, believe me. All of these plugins do a great job, and there were a lot of inspiration for what we wanted to put on the market. And of course, as the makers of IDA Pro and the decompiler, we were in a particularly good position to do so. And we first looked at those plugins for inspiration, see how they were doing things, what were the positive and negative aspects, because indeed collaboration means that we want to replicate changes made by one member of the team to the local copies used by the other members of the team, so that they can effectively and efficiently share their work. And in order to replicate those changes, well, there are many techniques that can be used, and they have characteristics ranging from robustness to fragility, or a lot of imposing a lot of constraints, or being very flexible. On the other hand, what we wanted to achieve is a solution that, of course, is at the same time robust and flexible. But how do we do that? And as a matter of fact, we decided to take a look at the other side of the fence, and that is into software engineering. And because in software engineering, collaboration has existed for a while now, for decades really, with the source code repository management systems like Git, Subversion, Perforce, CVS, and many others as well. They let the users focus on their work. They're not in the way constantly. They work reliably, and they provide an interface to incorporate the changes made by others in a reliable fashion. So we wanted to apply the same principles to reverse engineering workflows, and that is what became IDA Teams. So to give you a little bit of an idea how a typical IDA Teams deployment looks like, let's imagine first a company called Acme Corp, right? That has not yet switched to IDA Teams and is still using IDA Pro. It has 3 users, Alice, Bob, and John. And those 3 users are working routinely using IDA Pro, and every now and then they need to share information. And the way they do it, well, either they can use an existing plugin, which will sometimes do the job, sometimes not entirely, or they may simply use shared drives to exchange different versions of the databases, for example, or many other similar many other options to share their work. But most of them are not entirely convenient or have certain shortcomings. So they decided to switch to Teams, and then here's what it looks like, which is essentially the same thing. Plus, of course, as you have noticed, this big addition in the middle. So between IDA Pro and IDA Teams, one of the key changes is this big piece in the middle, plus a tool that we will come to shortly. So Alice, Bob, and John are still working with this central piece that we call the Vault server, which is a server that you would install on your premises. So in Acme Corp's case, at Acme headquarters, for example. So this central piece, which we call the Vault server, this is where all the revisions of certain projects are lying. This is where users store and commit changes to the projects that they're working on. Typically after a milestone, for example, they will want to share their work and they will commit a new revision of a certain project on the server. And then other users, of course, can think from that server, that in other words, pull from that server and incorporate those changes, into their own local copy of the project. With the help of the centralized server, we can provide interesting features such as diffing between revisions of the file. That means IDA gained a new mode where it can open two versions of the same IDB and show differences, the relevant changes between those two versions of the database. In a similar fashion, it can offer merging and also conflict resolution, including interactive conflict resolution, which we will come to later as well. Now, in addition to this, we came up with the IDA Teams client because we wanted to be able to get the best out of the Vault server. So we came up with this client, which we also sometimes refer to as HVUI. It's a full-fledged client, a full-fledged source code repository management client, which lets the users perform a ton of operations, just tracking files, committing, viewing the commits and the history for files, merging, resolving. It's extremely powerful. It is, as I said, full-fledged, but it is nevertheless just an interface to the server. And users will typically not spend a lot of time in the client. They will spend most of their time in IDA, just as before. In fact, IDA remains at the center of the workflow. So this is a very high-level overview of what IDA Teams looks like. And just to brush on the general concepts, but of course it was rather abstract. And we want also to give you a more concrete view over how it works. So we have two more segments coming up. One with a single user mode, which we will use to introduce the new tools, in particular the diffing mode and the IDA Teams client. And then we will move on to literally the most canonical use case for IDA Teams, which is multi-user collaboration work with IDA Teams. So without further ado, let's proceed with the first segment, which is the single user mode, just to introduce the new tools. And to do so, I will pass on the mic to Igor.
Hello, everyone. I will show you the single user mode. So I have started the server, the IDA Teams client, and the first time when I do it, it asks me to provide the login information. I will use the server that has been started locally and login information. And the first time I need to specify where on my hard drive I want to save the databases. I will use the directory created for this one, for this webinar. And here we can see that on the server we already have some files submitted by the manager, some samples, and I want to look at some of them. For example, this one. First, I will sync to the lead distribution, so it will copy the file to my local drive, so we can see it in the local files now. And then to start working on it, I will check out for edit and open it in IDA. So IDA has opened. it's been just auto analysis has been run, but nothing else. So I will look at, for example, list of imports and see what this file is using. For example, it seems to be using some functions from WinInit, such as internet open. Let's see where it's used. It's used in this function. It calls internet open and internet connect, so it looks interesting. So let's decompile it and see what's going on. So partly it's making a request and then reading the results into some buffer. So I will rename a couple of things just to make it a bit nicer. I will not do the full cleanup. And apparently this function should be called communications with command and control, probably. So let's assume that I analyzed this function, did everything. And now I want to commit my changes. And just to be safe, I will exit with save. And now I can commit from the work list view. And we can see that in the commits list, we have our commit, and we can check details that the file has been updated to version to revision 2. And just to demonstrate the diffing, I will do a bit more work. Let's look at the first caller. So you can see it calls get option action. So partly it retrieves some options from the server. Let's make a struct here. Rename a couple of fields. And rename the function. And before I commit, I will check my changes by using diff against the local file. And either run the special mode, diff mode. Just a second. So because IDB is not a simple text file like with source code, it's a hierarchical database. So we have different categories of items that are being compared. So we can set in local types, we have one item added, which is the option struct that I have created. And in the other categories, we can see that a function has been renamed. And again, the function has been renamed. And one more function has been decompiled. So that's it. It looks good. And we can commit. So like this, we can see, for example, we can check the file history. And for example, we can tell the manager to have a look at the history to see what's been changed, and they can actually go and see at every point what has been changed and also inspect the changes. So that concludes the demo of the single user mode.
Okay, thanks, Igor. Thanks for this introduction. So as was said previously, this is an introductory demo meant really to display how to use the IDA Teams client and what kind of features really it offers. Now we will be moving on to what is a more realistic use case for IDA Teams, which consists of having two users. You work at the same time on a similar project. We will not, in fact, be working exactly at the same time because it would be extremely confusing for the audience. So what we will do instead is that we will simulate the work by doing a little bit of work on my end, then a little bit of work on Igor's end, and then back to him as well. So we will start with some sample here. I will get the latest revision. I will start editing it inside of IDA. There we go. Notice that I'm using the dark theme to better mark the difference with Igor, who's using the default theme. So I will start my analysis as I often do when I'm reversing malware, which is that I will typically ask IDA to give me already a list of all the strings, the string literals that it managed to collect from the database. And we can see a bunch of what appears to be error-related strings. Then, well, here it's not entirely conclusive. In fact, it's rather strange strings. Maybe nothing interesting here, or maybe, what do I see here? There is this, for example. I can see that this string starts with a kind invitation to send some Bitcoins to some wallet. So that might be of interest. I'm going to jump there. And indeed, I'm fairly lucky here because I land in a space where we are literally surrounded with threatening, inviting messages. I will want to see who is using those. So I will be jumping to some code, and here I am inside of a function that is in fact referencing all of those. Send your Bitcoin, then Wosmith. This is an email address, your personal, blah blah. So I will want to decompile this. I will press tab, and here we go. I end up with a nicely formatted function that appears to be presenting the user with the invitation to send some Bitcoin. I will therefore rename this function display ransom message. That sounds like a fair name for a function like that. And while I was doing that, of course, Igor was not idle. So let's see what he's been up to.
Okay, so indeed I opened the same file as Arno, and currently I'm at deal entry point, but it doesn't look very promising. So let's look at the other entry points that that file has. So I will decompile it. And let's see. This is probably some initialization with SOC functions. And I will look at, for example, this create thread. So it creates a thread and runs this function in a thread. So let's see what it does. So we can see that it calls some function once, twice, 3 times, but strangely it looks a bit suspicious because there is the same argument being passed to it, and it's weird. So let's go inside and see what is happening. So apparently this function accepts arguments in the registers, which is why the compiler did not discover them. So if you go back now and refresh with F5, because that indeed the different arguments have been passed. So it uses an IP address of the local machine, then the local host name, and then the computer name retrieved by the get computer name function. So apparently it's collecting the addresses into some kind of a list, I would guess. So let's rename it to add entry, just to be generic enough. And now I will pass to Arno because he's been doing some analysis in the meantime.
Indeed, thanks, Igor. When we last left out, we were at this kind display ransom message function. Now I would like to see who is calling that function. So I will look at the list of cross references. There is only one, I'm lucky. So here we go. We end in this block with the call to display ransom message, and I can see that we are inside of a conditional block. I would like to investigate a little bit what's the condition here. So I will jump into this function, and as we can see, I will keep the analysis extremely short here, of course, for the sake of the webinar, but essentially this is about setting up some crypto. So I will rename the function accordingly. Setup crypto. So if I go back, I see that if setup crypto succeeds, then we do something, and then we display the error message. Now, this do something, I will investigate a little bit more by jumping into it, and I land in a function that appears to be doing a fair amount of path manipulation, in fact. We can also recognize some path-related string literals like dot, 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 or the star to perform wildcard pattern matching. All right, and we can see that it's looking for file extensions and comparing those file extensions against a list here of file extensions concatenated into a big string. So essentially, plays with path, looks for file extension, and if it finds one, it does something. If not, it calls another function. Well, actually, this other function is ourselves. You see, 1973. This is ourselves. So this appears to be a recursive function that walks into the file system, and then when it finds the files of interest, does something. So I will already rename this function walk file system, because this appears to be a pretty good name for it. And that is it for me at the moment. Let's see what Igor has been up to.
All right. So let's see. So we're still in this function that gets the machine name, computer name, and adds to the list. So let's look at what other function it's calling. So it creates a new thread. Let's see what this function does. So it gets the adapters info, gets the IP addresses, and we can see again that add entry is being called. So apparently this is enumerates the local adapters and gets their addresses. Okay, that's good. Then the next one, there is a loop and two functions. So this one gets get extended TCP table. So this gets a list of connections to the current machine and adds them to the list again. So let's call it enumerate TCP connections. Okay. Third one. This one gets IPNet table, which is the so-called ARP table. So again, it tries to retrieve addresses, probably for spreading. So let's rename it. And this one is protected by an if. So it's run only once. What it does, it gets a list of servers, adds them to the, gets some kind of server, adds it to the list, and then calls itself again. So let's call it num servers. And this one we can convert to decimal. So we can see that it slips 18 seconds between each iteration. So apparently this function is responsible for collecting addresses for spreading. So let's rename it. Where is it? So this one looks good as a place to stop for the moment. So I will exit IDA and save and submit my changes as noise address collection, for example. There we go. It's been submitted, and now let's see what Arno is doing.
Well, thank you, Igor. In fact, where we last left off was at the discovery of this work file system function here, the recursive function. And something we left on the side at the moment is what happens when the program finds a file whose extension is one of those that are that it is looking for. So let's jump into this function to have a look. So what we can see is that it's doing some file manipulation function. And in particular, this is of interest to me, like crypt encrypt, without going into excruciating details and a full-blown analysis here for the sake of the webinar's runtime. I will nevertheless deduce that this function is about encrypting the contents of a file and then persisting that to the disk. So I will rename the function accordingly, and it appears to me something like encrypt file is a decent name for it. So I will go back one step, and I can see that we are back into this work file system function, the recursive function, and when it finds the file of interest, it encrypts it. I see. Okay, so let's go back one more step, and we are back to this if block, where if setup crypto succeeds, then we can walk the files. We start walking the file system, which will then also encrypt the files of interest and then display a ransom message to the user. This is good. I am fairly satisfied with this work so far. So I will call it a milestone. And more importantly, I will make this available for my colleagues to use. So I will want to commit that to the server. And I believe a description such as labeled some encryption thread routine makes sense. So I will commit that. I will send that for others to use. And what's happening here is that the server rejects my commit, which is expected because, in fact, Igor just committed before me. And since I did not incorporate his changes into my local copy, well, I need to do so now and resolve the conflicts, if any, and then I will be able to submit. This is exactly the same as for regular revision control for software engineering, if you've ever used it. So, understood. I will therefore save my commit. You can notice the little red triangle here at the moment, which is the client's way of telling me, hey, you're outdated. You need to do a resolution before submitting. Now we can see that from the context menu, we have a bunch of options for resolution. We have auto resolve if no conflicts. This is in fact a safe mode. This is this will only succeed if there were no conflicts found between the two databases, the one from Igor and my current database. Then the second one is auto resolution, but we prefer the local changes in case of conflict. Or auto resolution, but we prefer the remote changes, in this case, Igor's changes in case of a conflict. Then we have the full-blown interactive merge process. We will come to that later. And then we have two other modes, which are a little bit more expeditive in the sense that it's either I completely use my IDB, my local copy of the database, and I ignore all remote changes, or I entirely use Igor's database and I completely trash my changes. In this case, in fact, I know that we won't have a conflict, so I will use the auto conflict resolution. And as we can see, the client, the IDA Teams client, tells me that we successfully resolved this file. So all is good. I can now effectively commit my changes for the team to use. So there we go. And of course, let's see what Igor has been up to in the meantime.
All right. Just a second. There you go. So we're in this function that we have just analyzed, and let's see. It's being called. It's being called in the, well, not called, but it's been a parameter to create thread in the entry points that we've been analyzing. I will skip most of this for now, and I will look at this one, which looks interesting for me because it's called between the two sleep calls. So let's see what it does. So we can see that it gets logical drives, then enumerates them, builds a path name. So just to make things a bit nicer, what I can do is retype this one. Currently it's been detected in 64, but you can see that it's actually a string of characters because it's being passed to get drive type W. So let's retype it to a white char array of 4. Oops. Just a second. Made a typo. There we go, and now it looks much better. And this one is actually compared with the result of get drive W, which is the type of the drive. So I can convert it to symbolic constant. They usually begin with drive, so I type drive because indeed it's actually drive fixed. So apparently this looks for fixed drives and calls some other function using it. So let's rename it to enumerate drives, for example. And this one looks good as well. Well, for now, let's commit code on drive enumeration. But it doesn't work because we are not in the latest revision. So we save our description and try to resolve. It works because we worked on different places. So now I can commit. There we go. And back to Arno.
Thanks, Igor, and thanks for your contribution to the project. So we are back to where we were before in around this interesting block here, and the rest of the function is not particularly interesting, but nevertheless, what I would like to know is who is calling this. So I'm lucky. There's only one place where we call it, and it appears to be passed to create thread. Which is, by the way, why IDA automatically renamed it as start address. But I think I have a better name for it, such as thread encrypt proc. Kind of makes sense. Now let's have a look at the bigger picture of the function, I would say. Looks like we are iterating on logical drives for I31, blah, 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 get logical drives. Yes, okay. So the looks of this function might remind you something, and that's because it's exactly the same function as the one that Igor just analyzed. Well, this is obviously on purpose. This is to show you what happens when we have a conflict because we are modifying concurrently the same things. So, but let's pretend I don't know that. So I will rename simply a variable that I don't find convenient, root path name. To me, path better. So this is shorter. I see that we are iterating on the drive. 65 looks like a well-known ASCII value to me. So this is indeed the A ASCII character. So this is already pretty good. I think I will already commit this and make it available for the rest of the team to use. So I will want to save IDA. There we go. And then commit it. I will claim that I started investigating the drive iterating function. That sounds good. Let's commit this. And once again, we have the server telling us, up, not so fast. You first need to merge the other changes which were performed by the rest of the team. And indeed, this is once again due to Igor's work. So in this case, I happen to know that we worked on the same area of the file. So if I attempt an auto-resolve, it's going to fail. And eventually, I could either select to auto-resolve but prefer my changes, or prefer Igor's changes in case of conflict. But for the sake of the demonstration, we will instead go to the full-fledged interactive merge. And in this mode, IDA starts with a 3-panel desktop, a little bit squeezed here for the webinar, but here we can see at the center the common database. So that's the common ancestor before my changes and before Igor's changes. On the left, there is the local changes, so the changes that I made, and on the right, the remote state, so the database coming from Igor. In fact, at the bottom we have some details about the nature of the changes here. We are in fact currently looking at the stack frame of a specific function, which is of course the drive iterating function, and I can see that root member path name was renamed to me into path. Okay, so I in fact prefer my name. So in this case, I will pick up my change. You will also have noticed that IDA is showing here the list of steps in a very similar fashion as to what it did during the diffing. And as Igor mentioned in the previous section, this is due to the fact, sorry, that IDA databases are not simple text files. And it is fundamentally more complicated to diff and merge with IDA databases than it is with text files. So we have this structured diffing and merging on purpose. So as I said, in this case, I prefer my change. So I will pick up the right action. There we go. Ploop. We will then automatically move to the next change. And in this case, we can see that especially if you look at the details, it's going to be even more simple. You can see that the most important bit of change here is the change to the wcar4 array. So this is very important. In this case, I will pick up Igor's change because I think it makes more sense. And there we go. IDA is already happy because we have resolved all of the conflicts. So that's good. We can now go and save the resulting database. And now we can finally commit the way we wanted to. So this is it in a nutshell. This is what IDA Teams is about. This is about collaborating on similar projects and having the ability to perform differences between different versions of the same project, or incorporate changes or resolve conflicts. In this particular section, of course, we laid it out a little bit thick in terms of conflicts on purpose because we wanted to show how exactly users work with IDA Teams when they need to resolve some conflicts. So as you have seen, there are multiple options for resolving conflicts, and the most powerful and fine-grained one being, of course, the interactive merge that we last displayed. And in a sense, this is the use case that IDA Teams is initially designed for, keeping in mind, of course, that it will keep up maturing with more capabilities in the future. But in a nutshell, this is it. So this is it. This is what we have as demonstrations. So I will hand over the mic. So Chaim, maybe if you can pick up.
Yeah, let's say first of all, we have 2 questions. Look on the Q&A, and he said, is it possible to use IDA Teams to move symbols from one IDB to another IDB? That's the first question. Can you answer, Arnold or Igor?
So it is absolutely possible, but it depends if those 2 IDBs are vastly different. You may have to do more conflict resolution that you would like. So moving symbols, if it is strictly about symbols, at the moment you have multiple options. IDA Teams can be used to do that. But if the binaries that those 2 symbols come from are very different, and therefore the databases are very different, it may be a little bit tedious to do so with the merging approach in IDA Teams. This is IDA Teams really excels at incorporating changes done on a single file. So it really depends on how different the 2 input databases are. it can be either working as a breeze, or it can require a little bit of work.
An additional question of does IDA Teams support branches, rebases, and other Git commands?
So branches, at the moment, the answer is no. The rebases, not as such. Well, this is in fact what happens when you do some conflict resolution. In fact, this is very similar to rebasing, but it is less flexible at the moment than Git is. But Git is exceptionally flexible. But at the moment, we have rebasing working, but in a forward fashion.
Okay. Guys, any other question to our expert? You have Q&A and chat in the below if you want to ask any question, Arnaud or Igor. So everything is clear, not to me, but maybe to you. Anyhow, Arnaud and Igor, it was a pleasure to host you with us, and we will follow up with all audience and participants. Thanks a lot to all of you, and goodbye.